Hello, today we are going to learn about the laws of logarithms. There's 4 of them, and I'm going to show you an example of each and why it's important to know how to do them. Okay, first let's look at what they are. There's the 4 laws of logarithms. You might want to pause the video and take these 4 down in your notes. This part right here just defines the variables that are given to you. So, the log of a product is equal to the log of each individual factor summed. The log of a quotient is equal to the difference of the log of the numerator and the denominator. If 2 logs are equal to each other with the same base, then that implies that their arguments, the insides, have to be equal to each other as well. And a log of a value raised to a power is equal to that power as a coefficient of the log of just the base. And again, this is only defined where m, n, and b are greater than 0, b cannot be equal to 1, and m, n, b, and k are all real numbers. Okay, so again, it might take a second to write this down, and you'll get an idea of how these are used in a second. Okay, I'm going to move on to look at an example of each of them. Okay, so here we have log base 5 of 50 minus log base 5 of 2. Now, if we wanted to evaluate this, this would be difficult to do because we can't evaluate what power do we raise 5 to get to 50. We also can't evaluate what power do we raise 5 to get to 2. But we can use the rule that states that if you have 2 logs subtracted from each other with the same base, it's really, you can rewrite it as the quotient of the 2. So I can rewrite this as log base 5 of 50 divided by 2. 50 divided by 2 is a nice one because it goes in evenly, so log base 5 of 25. Now this becomes an easier log to evaluate because 5 raised to what power is equal to 25? This entire log is equal to 2. So this subtraction problem up here with these 2 logs is really equivalent to the value of 2. Okay? So again, that was using this property right here where we went in reverse, but if you have 2 logs subtracted from each other with the same base, you can rewrite it as the quotient of the 2 arguments. Okay? Let's look at the next example. We have log base 6 of 3 plus log base 6 of 12. Again, this is going to be difficult for us because we can't figure out what power we would raise 6 to get to 3. It's not a rational number. And we can't figure out what power we would raise 6 to get to 12. Again, it's not a rational number. So we'd have to use one of the laws of logs if we were going to evaluate this. The bases are both 6, so we can actually use the fact that the log of the product of these 2 would equal the sum of the logs of the factors. So we can combine these into a giant multiplication problem, so that gives me the log base 6 of 36. And again, this is easier to evaluate. 6 raised to what power is equal to 36? So again, like the previous example, this whole thing reduces to 2. This whole expression has the value of 2. Okay? Alright, moving on to the third example. Log base 2 of 8 raised to the x power. We don't know what 2 raised to what power will give us 8x, or even if you do, sometimes it's easier to rewrite it. So we can use the power rule and say that this x value right here can become the coefficient of the log. So we have x times log base 2 of 8. And this we can evaluate. 2 to what power is equal to 8? That's 3. So this is really x times 3, or we're used to seeing this written as 3x. So the value of this expression is really 3 times the exponent. Okay? One more. What happens if we have the natural log of x plus 2 equal to the natural log of 3? Well, natural log is implied, well, its base is implied. The base of a natural log function is e. So because these have the exact same base, we can set the arguments of this log function equal to itself, equal to each other. So we'd have x plus 2 is equal to 3. And if we wanted to, we can solve for x in one quick, easy step, subtracting 2 from both sides. So that's the value of being able to set the arguments equal to each other if you have 2 logs that are equal to each other with the same base. Alrighty? And those are the 4 laws of logarithms.